you don't need to see the keylog file to see what I'm doing over here. So what we're going to do is that we are going to try. So first triplet is 319. So I'm going to put in 3 goes to. So 3 goes to 1, which then goes to 9. That is what's going to get added to the graph, okay? Then next line is 6, 8, 0. So we add those nodes to the graph, and voila, right? So next line is 1, 8, 0. We add 1 to 8, and then 8 to 0 already exists, so that's fine. Then 6, 9, 0. So now let's go ahead and draw this guy over here. 6 to 9 to 0. Okay. And then 1 to 2 to 9. So let's go ahead and put a 2 up here. 1 to 2 to 9. Okay. Also, I don't think this graph is planar, or planar, which means that and that's just a fancy mathematical way of saying I don't think I can draw this graph without lines crisscrossing each other. Okay? So 6 to 2 to 0. So 6 right here, 6 to 2, and now to 0. And then 7 to 6 to 2. 7 to 6 to 2. 6, 8, 9. Okay. 7, 6, 2. We already have. 3, 1, 8. We already have that. 3, 6, 8. Okay. 7, 1, 0. So 7 to 1 to 0. Okay. 7 to 2 to 0. I know it's looking messy. 7 to 2 to 0. 7, 1, 0 again. 6 to 2 to 9. Okay. 1, 6 to 8. So this gives us information that 1 is before 6. Okay. 1, 6, 0. That was an edge we could infer pretty easily. And 6, 8, 9, 7, 7, 1, 6. And then finally 7, 3, 1 and 7, 3, 6. All right, so that I have enough nodes finally that I can start Kahn's algorithm, or that I can start showing you. So the way Kahn's algorithm works is says let's identify the node find all the nodes within n degree 0. Now for this one, there's always going to be only one node within n degree 0. Okay? Make sense?
Yep.
So the way it's very easy to implement.
Sorry to interrupt. Can you just say again really quickly why you set this up the way you just did?
So I'm reading the file and I read the number 319, okay?
Mm-hmm.
So the idea here is that what we're tracking with the graph is the node and the relationships. The nodes and the relationship between them. So the nodes are the number. The relationship between the numbers are which number comes before which other number. So because we've got 319, we know 3 comes before 1 and 1 comes before 9. Make sense?
Mm-hmm.
And that's all these arrows are. So we've recorded at some point that a 7 comes before 6, and we've recorded at some point that 6 comes before an 8, as well as 6 coming before 0 and 6 coming before 9. Make sense? Or no?
I'm not really. I'm confused by so the 1 points to the 6 because the 6 is greater than the 1, right?
No. 1 points to 6 because we had a number like 106.
Does it matter the value? It's just when they're input into the graph?
We had the value 160 at some point. so that means that the person pressed the 1 button before they pressed the 6 button. And then
Okay.
they pressed the 0 button. So 1 led to 0, 1 led to 6 and 6 led to 0. We're looking, this is a sequence of key presses. Okay? So we saw that somebody pressed 319 as a key press. So the 3 comes before the 1 and the 1 comes before the 9. Does that make sense?
Yeah.
So we're seeing which button got pressed, right? And then we're seeing, the arrow indicates that basically this one came before this one. So that's what the relationship is. So we're trying, and what we're doing is that basically is that the password scheme for the problem, right? Just as a refresher, is that we've got some full password and it's asking for certain character. It's asking for like maybe the first, the 7th, and the 9th character of the password, or the first, the 3rd, and the 7th. But it's never going to ask for them out of order. So it's never going to give us the 2nd, the 1st, the 3rd. It's always going to be like 1st, 2nd, 3rd, or 1st, 3rd, 5th, or 2nd, 3rd, 5th, or 2nd, 3rd, 4th. Make sense?
Yes.
Right? So now that we know that, we're trying to recreate the original password. So once we gathered enough data in our graph, we can modify Kahn's algorithm a bit, which in this simple form means basically look for the thing within in degree of 0. In other words, a thing that has nothing else leading into it, which is 7. 7, nothing comes before 7. So I'm going to write 7 down. Okay? And then I'm going to delete 7. And as a result, I have to delete all the things that are, all the edges that are attached to the 7. Okay? So see how I deleted 7 and all the things attached to 7?
Yeah.
Okay. Now I repeat. Look for the thing within in degree of 0. So 3 has an in degree of 0. I'm going to write that down. Okay. Write down 3. And then I'm going to erase all the edges that were associated with 3. And I repeat. What has an in degree of 0? 6 has an in degree of 0. So I erase all the things with an in degree of 0, erase all the things that were attached to 6.
I think it was 1. Because 1 was going into 6.
Oh, yeah, you're right. This is why computers do that and not me. So I'm going to delete the 1. All right. And at this point, actually, we're kind of stuck because we didn't read the whole file. Oh, no, there was an edge from 6 to 2. Okay. That I think I accidentally deleted and didn't restore. And now we repeat. We delete 6. And then at this point, we're kind of stuck because we didn't read the entire thing, right? Because we've got a 2 and an 8. Okay? It's also possible I erased part of the graph, you know? When I was doing my erasures. Or erased an edge I shouldn't have when I was doing my erasures. But the point being is that you keep looking for the node that has an in degree of 0 and removing it. And that will remove all the associated edges with it. That makes sense?
Yep.
So are we done now?
Once
Based on in degree of 0?
when the graph is empty, you're done. So the only reason I wasn't able to get to an answer is I didn't read the entire file in, or I didn't do my work on the entire file.
Mm.